Okay, so in this video, I want to solve a problem using inverse matrices and kind of talk about a little bit more about inverse matrices. So this is part 3 of example 1.79. So L of x, y, z is equal to x times 1, 0, 1 plus y times 1, 2, 0 plus z times 2, 2, 0. And we want to solve the equations LV is equal to 1, 1, 0, and LV is equal to minus 1, 1, 3. Okay, so notice how you would normally do this without using inverses is you would put the equation into a matrix, into an augmented matrix, 1, 1, 0, like this, and then you would row reduce. And in this particular problem, you'd end up with the identity matrix on the left-hand side. And let's say, we'll just say triangle on the top entry for whatever it is, square in the middle entry, and circle in the bottom entry. Then x would be triangle, y would be square, and z would be circle. Okay, and then to solve the minus 1, 1, 3 thing, basically, you would just put in minus 1, 1, 3, and go through this whole process again. Well, the idea is that all of the row reduction steps are completely dependent by what's going on the left-hand side. And the row reduction steps are going to be the same no matter what this step is. The only difference is going to be how this changes. So in inverse, basically, finding the inverse matrix, basically encodes this row reduction so you don't have to do a row reduction every time. Okay, you just do one row reduction, and you can use that row reduction to kind of figure out what how to solve mv equals w for any vector. Okay, so this is going to be 1, 0, 1, 1, 2, 0, 2, 2, 0. We augment with the identity matrix. Okay, and so again, we're going to swap the first or the second and third rows. So this is 1, 1, 2, 1, 0, 0. Now this is 1, 0, 0, 0, 0, 1. Then this is 0, 2, 2, 0, 1, 0. To subtract row 1 from row 2. So 1, 1, 2, 1, 0, 0. 1 minus 1 is 0. 0 minus 1 is minus 1. 0 minus 2 is minus 2. 0 minus 1 is minus 1. 0 minus 0 is 0. 1 minus 0 is 1. 0, 2, 2, 0, 1, 0. Okay, and I'm going to multiply row 2 by minus 1. So take away these negative signs and then add 1 there. Okay, now the next thing that I'm going to do is I'm going to divide row 2 by, The next thing I'm going to do is subtract 2 times row 2 from row 3. So 1, 1, 2, 1, 0, 0, 0, 1, 2, 1, 0, minus 1. 0 minus 2 times 0 is 0. 2 minus 2 times 1 is 0. 2 minus 2 times 2, that's 2 minus 4, that's minus 2. Got that wrong in the last video. 0 minus 2 is minus 2. 1 minus 2 times 0 is 1. Okay, 0 minus minus 2, that's going to be a 2. Okay, so now what I'm going to do is I'm going to divide row 3 by minus 2. So 1, 1, 2, 1, 0, 0. 0, 1, 2, 1, 0, minus 1. This is 0, 0, 1, 1, minus 1 half, minus 1. Okay, now I'm going to subtract 2 times row 3 from both row 1 and row 2. So for row 1, 1 minus 2 times 0 is 1. 1 minus 2 times 0 is 1. 2 minus 2 times 1 is 0. Okay, 1 minus 2 times 1, that's 1 minus 2, so that's minus 1. Okay, now 2 times minus a half is minus 1, and it's 0 minus minus 1, so this is going to be a 1. And similarly, 2 times minus 1 is minus 2, and it's 0 minus minus 2, so that's going to be a 2. Okay, for the second row, 0 minus 2 times 0 is 0. 1 minus 2 times 0 is 1. 2 minus 1 times 2 is 0. 1 minus 2 times 1 minus 2 times 1 is minus 1. Similarly, this is going to be a 1. Then minus 1 minus 2. So minus 1 minus 2 times minus 1 is the same as minus 1 plus 2. So this is going to be 1, and the bottom row now stays the same. Okay. Whoops. Okay, now what I'm going to do is subtract row 2 from row 1. So 1 minus 0 is 1. 1 minus 1 is 0. 0 minus 0 is 0. Minus 1 minus minus 1 is 0. 1 minus 1 is 0. 2 minus 1 is 1. And then this is 0, 1, 0. Minus 1, 1, 1. 0, 0, 1, 1. Minus 1/2 minus 1. Okay, so this is M inverse. Okay, so how do we use M inverse? Well, we want to solve the equation LV is equal to 1, 1, 0. That's the same as the equation MV is equal to 1, 1, 0. Okay, so how do we solve this equation using the inverse? Well, it just says V. We're just going to multiply both sides by M inverse and get that V is equal to M inverse times 1, 1, 0. So this is M inverse. So this is 0, 0, 1, minus 1, 1, 1, 1, minus 1/2, minus 1. And we're going to multiply it by the vector 1, 1, 0. Okay, the top entry is going to be 0. The bottom entry is also going to be 0. Or sorry, the middle entry is also going to be 0. And the bottom entry is going to be 1 minus 1/2, which is 1/2. Okay, so what we're saying then is that M times 1/2 is equal to, or sorry, M times this vector is equal to 1, 1, 0. So let's test that out. So you can scroll back above. M is equal to 1, 0, 1, 1, 2, 0, 2, 2, 0. And we're going to multiply it by 0, 0, 1/2. Okay, the first entry is going to be 0 plus 0 plus 1/2 times 2, which is 1. The middle entry is also going to be 1, and the bottom entry is going to be 0. Okay, so everything checks out for that problem. Okay, so the inverse, so the solution to MV equals 1, 1, 0 is the vector 0, 0, 1/2. Okay, so similarly, if we want to solve the equation LV is equal to minus 1, 1, 3, this is the same as solving the equation MV is equal to minus 1, 1, 3. And so V, the solution, is going to be M inverse times V. M inverse is 0, 0, 1, minus 1, 1, 1, 1, minus 1/2, minus 1. And we're going to multiply it by minus 1, 1, 3. Okay, so the top entry is going to be 3. The next entry is going to be minus 1 times 1, or minus 1 times minus 1, that's 1. Plus 1 times 1, that's 2, plus 3, that's 5. And then in the bottom, let's take this slowly, minus 1 times minus 1, that's minus 1. Minus 1 minus 1/2. So it's minus 1 minus 1/2. That is minus 3/2. So it's minus 1 minus 1/2. That's minus 3/2, or minus 1.5. Okay, and then we're going to subtract off 3. So that is minus 4.5. Okay, so what I'm saying is that M times this vector is going to be equal to minus 1, 1, 3. Okay, so again, M is 1, 0, 1, 1, 2, 0, 2, 2, 0. Now I'm going to multiply it by 3, 5, minus 4.5. And what do we get? Well, the top entry is going to be 3 plus 5, that's 8, minus 4.5 times 2. So 4.5 times 2 is 9, so that's 8 minus 9. So this is minus 1. The middle entry is just going to be equal to 3 times 0, that's 0, So again, it's going to be 10 minus 4.5 times 2, so that's 10 minus 9, so that's 1. And then in the bottom, it's just going to be 3. Okay, and that's equal to that. Okay, so that checks out. Okay, so the idea is if you want to solve the equation mv equals w, then you can just compute v is equal to m inverse times w. Okay, now of course this only works if m is invertible. If m is not invertible, you can't do this. If m is not invertible, you have to do something else. But the basic idea is that instead of having to row reduce the same matrix or a very similar matrix every time you have a different w, you can compute m inverse, and then v is just going to be equal to m inverse times w. Okay, and lastly, I just want to show you that m times m inverse is equal to the identity matrix. So m is 1, 0, 1, 1, 2, 0, 2, 2, 0, and then m inverse is 0, 0, 1, minus 1, 1, 1, 1 minus 1 half minus 1. Minus 1, yeah. Okay, so let's do this matrix multiplication. Okay, so we'll do the first column first. So remember the way that we do matrix vector multiplication. Okay, so the first column, or so the top left entry is going to be 0 times 1 plus minus 1 times 1 plus 2. So it's minus 1 plus 2, that's 1. The middle entry is 0 times 0 plus 2 times minus 1 plus 1 times 2, that's 0. The bottom left entry is 0 times 0. Well, the bottom, m has a 1 there. M has a 1 there. Sorry about that. Okay, so now the bottom entry is going to be 0 times 1 plus minus 1 times 0 plus 1 times 0. So that's going to be a 0. Okay, the top row middle entry is 0 times 1, which is 0, plus 1 times 1, which is 1, plus 2 times minus 1, so that's 1 minus 1, so that's 0. Then the middle entry is 0 times 0, plus 1 times 2, that's 2, minus 1, so that's 1. And then the bottom entry is also going to be 0. Okay, the top right entry is 1 times 1, plus 1 times 1, so that's 2, plus 2 times minus 1, so that's 2 minus 2, that's 0. The middle entry, 1 times 0, 0, plus 2 minus 2, so that's 0. And then for the bottom row, 1 times 1 is 1, plus 1 times 0, plus minus 1 times 0, so this is 1. Okay, so this just verifies, in this case, that m times m inverse is equal to the identity matrix. So in other words, when we have an equation like mv is equal to w, when we multiply on the left by m inverse, this is just the identity matrix times v on the left-hand side, and it's m inverse times w on the right-hand side, but the identity matrix times v is just equal to v. Okay, so this is a video kind of talking about how to find inverse matrices and what to do with them once you find it. I hope you found it useful.